So continuing on with the discussion of the three definitions, electronegativity, electron affinity, and ionization energy, we're going to focus on really two of those three. I'm going to write a chemical equation. I would like you to think about whether this equation would represent electron affinity or whether it would represent ionization energy. Sodium plus an electron yields Na negative. So are you adding an electron or are you taking an electron away? You're correct, you're adding an electron. So this equation deals with electron affinity. I'm going to write another equation. Does this equation deal with electron affinity or ionization energy? There you go. So that one also deals with electron affinity because we're dealing with adding an electron. But there is a difference in these two equations. So what about energy? Let's see, put it down here. So energy, there isn't change in energy every time. Energy can either be out or energy can go in. If you remember the definitions that I gave you the other day, or if you watch the PowerPoint like I asked you to before you watch this video, you will remember that energy out is the norm. Most things release energy. So this would show that energy would be released if I put energy on the right side, because that would be a product of a chemical reaction. That would say that a sodium atom plus an electron makes a negative sodium ion and energy is released. However, down here, energy would go on the other side. You wouldn't know that yet, but you will in just a second. It'll make sense. So here, this would read energy plus neon plus an electron yields a neon negative ion. So energy goes out in most cases, but sometimes energy goes in. It goes in for all elements that end in S2 or P6. In other words, if there's a full sublevel, energy will be required to make an electron stick. That is, if there's a full S sublevel or P sublevel. D sublevels will generally still release a little bit of energy when you add an electron. A full D sublevel will still release energy, but not as much as you would expect. All right, so those are your energy changes for electron affinity. Most of the time, energy is released, but if you have an S2 or P6, which is neon, by the way, it's P6 because it's in the last column on the periodic table. So if you have an element with a S2 or P6 sublevel, energy will be required. Okay, energy out, we call a negative energy change. Energy in, we call a positive energy change. So negative energy change means energy was lost. A positive energy change means energy was required and you had to put the energy into the process. So that brings us to ionization energy. If we're talking about losing an electron, it would seem to make sense to write Na, for example, minus an electron would give us Na plus. But we don't write the equation that way because chemists don't like a negative sign in their equation. So instead, what they'll do is write Na yields Na plus, and an electron will be released. So if you remember back to your math class, if I added an electron to both sides of that equation, wouldn't the electron be lost? So I'm taking an electron away here from this side and moves it over here, so it's not there. So now I've got a sodium atom that turned into a sodium ion, and an electron is released by itself. Now, where does energy go? Well, energy always has to be put in to removing an electron. So the sign on the energy change will always be positive, because energy is always required, no matter what atom, it's always required to remove an electron. So that brings us then to the last point that I wanted to make. It has to do with energy change. So if I put energy into a process, if I could say energy is over here, and I put energy into it, does that resulting product, whatever you get up here, is that going to be at a higher energy state or a lower energy state? Well, if you put energy into the process, it's going to be at a higher energy state. So anytime you have some kind of process and you put energy in, you have a higher energy state. So energy, I'm going to write that down, energy in, higher energy. That seems kind of to make sense, doesn't it? Okay, but if energy comes out, that would be what kind of energy state? That'd be a lower energy state. Which one of these is a natural process? That one. Things tend to go to lower energy state. All right, so if I ask a question and say, well, suppose you have this equation. Where should energy go? You know that's ionization energy. Ionization energy always is always positive. Energy is always required to remove an electron, so it'll be over here. So really what that means is, if I ask you, and I said, which is higher in energy, this or Na plus, you know it's Na plus that's higher in energy because you had to put energy in. Remember? Energy had to go into the process. If I ask you which is higher energy, Cl or Cl minus, you would say that Cl was higher energy, because when you add an electron to most things, energy is released. Up here, which is higher energy, it was Na. No. I'm rushing because my wife told me dinner was ready. It'd be right here. Tonight was her night to cook. So here the energy is higher for the sodium ion because you had to put energy into the process. Here the energy is higher for the chlorine because energy was released when you add an electron. If I said which is higher in energy here, neon or Ne minus, the answer would be Ne minus, because neon is a P6, and so it requires energy to make an electron stick on to neon. So I'm going to stop there. We'll talk more about this in class this week, but this is a head start on the concept of energy change when you're adding or losing electrons. And that's the end for right now.